welcome to Fundamentals of Physics with your host, Scott Clark. Now today we're going to be talking about sound and how it travels. But first we need to understand what sound exactly is. Sound is a type of energy that's made by the vibrations that pass through a medium such as the air we breathe, gas, solid like a table, or even water. Now these vibrations, they shake the air particles, which cause them to shake the air particles around them and so on, which is the wavelength, and eventually they hit your ear and your ear picks up the frequency, which is the number of repetitions that occur in a wavelength. Actually what you're hearing vibration, so if you didn't know that, that's a good thing to know. Now sound travels in the form of a wave, which is dependent on speed and density, and also how far it has to travel. When something sounds deeper, it's said that it has a low frequency, and the wavelengths are farther apart. But when it's said to have like a high pitch, it's said that the wavelengths are real close together. I'm going to show you exactly how to prove that, basically. All you really need is some string or tension. Today I'm going to use my guitar string, my tension up here and down here, which causes the string to be taut. But yeah, that's all you really need. Now we're going to look at one thing. Why is it that they're all the same length, but they all produce a different frequency? Well, that's where the density comes into play. I don't know if you can see, but up here the strings are a lot thicker than the ones down here. Now if I were to change the tension of the string and actually right here cut it in I'm actually cutting it in half, which is, this is actually the same note, but because I'm cutting it in half, I'm doubling the frequency, which means it's still vibrating at the same time, but half the distance, which means the waves are a lot closer together. So in conclusion, what have we learned today? Well, sound is an energy that vibrates the air, causing it to produce a frequency that your ears picked up. It's dependent on density. It's dependent on the length and speed it has to travel. We also learned that lower frequency has a lower wave. Higher frequency will have a higher wave. And yeah, well, that's pretty much it. Well, I hope you learned something. If not, tune in next week where I'll teach you how to make a cat launcher or a catapult. Ha!